into more derivatives.
This one, it doesn't. But later on, we'll talk about what the changes mean.
Okay, I know that would be the same for this one, but I meant like other functions. Are we going to do that?
Why is the derivative?
We'll do something about the other derivatives. Blake.
How many derivatives are there?
Okay, alright. So the question on the floor is, how many derivatives can you take? Or how many derivatives are there? You can take as many derivatives as you want. The meaningful derivative you get is the second derivative. So you only have to do it twice, generally speaking. But you could take an indefinite number. But generally, you don't take it beyond the second derivative.
So we haven't been getting the right thing if we only take one derivative?
Oftentimes you get
What?
to 0 though, right?
Because we've only been doing one derivative.
Right.
So is that
So,
not...
but taking the second derivative is the same process. It's just the interpretation is different. So far, when we say we take the first derivative, we're looking at the slope of a function, right? So what does it mean to take a second derivative? And we're going to get to that later. Okay? So the process of taking multiple derivatives, the process is just the same.
So the
Go
slope,
from original function to the first derivative, that process is the same. From first derivative to second derivative, the process is the same. Okay? Interpretation changes from derivative to derivative. All right. 13. Graph analysis. What are we doing? All right. Match the graph of each function in A to do A to D with the graph of these things. So take a moment to see if you can match. So this is the original function. A, B, C, D are the original functions, and these are the derivatives.
Ooh. B and 4 look like they go together.
Okay. Just take a moment to yourself. Take a moment to yourself. All right. And I will do the same. So, should I stop recording while I do this? I should probably stop recording. All right. So, this is what I got. I got 2, 4, 1, 3.
yeah, I got 4 for number 2.
Wait, I got 3 for number 3.
Yeah, 2,
I got that.
and
I
then
got 2, 4, 1, 3.
4,
Wait, no, I'm doing it wrong.
Yeah.
I got what you got.
and then
Okay.
3.
Questions?
Can you work through that?
All right. So, the easiest thing for me to do is look for where it's zeros. So there's a 0 there, there's a 0 there. So that means it has to cross the x-axis at those 2 points. Well, this one doesn't. This only crosses the x-axis at 0. This one crosses the x-axis here. So that's probably it, but I'm going to check the other ones. This one crosses the x-axis 3 times, so that's too many times. And this just looks funky. So that's how I got 2. So this is the only one that matches at all. Right? And then I double check the sign, S-I-G-N. So left of this point is decreasing, so that means its slope is negative, right? So it's negative here, so that's it. So I just confirmed that by looking at that. Just looking at the sign of the slope.
Can't you just see, like, if it's a cubic, then it would be a quadratic?
You could, but I wouldn't bet on it. What if I give you multiple quadratics as a choice? Yeah. You had a question?
So you don't look at it from left to right?
I did.
Well, then how would that be negative? Like the way that...
The slope is negative, right? Left to right?
Yeah.
So that means the y values have to be negative. Remember, the slope of the original function is the y value of the derivative. So slope is negative, so the y values have to be negative.
If they're positive, y values have to be positive.
Correct. Right? So here, it's the slopes are positive in between these two, so the y values have to be positive.
So it's always going to have the same x values and poles?
Yeah. Let's look at the next one. Here, the slopes stay the same the whole time, right? This is the only one where the slopes, or there's a constant. So this is like a positive 1 or positive 2 slope. There's a positive 1. This is a negative 2 or negative 1 slope. There's negative. Positive slope, positive. So that's it. That's 4.
Looks like a dude squinting.
What does it look like?
A dude squinting.
Yeah.
Okay? This one there's only one place where the tangent line is horizontal, and it's at x equals 0, and both of these have x equals 0, right? So choice 1 and choice 3 have a 0, but this one, choice 3, has two other places, but this doesn't happen. It only happens in one place. So these two go together. 1 and choice C go together.
Can this be on the test?
It is on the test.
We have like 20 problems with that?
No. I don't need to ask you 20 times to see if you know how to do this.
You need to make my point.
All right. And then 3, it's probably just one question. Here's 3. This has 1, 2, 3 places where it's 0. Right? So that's this one. Or process elimination. There's 3 places where it's 0. 3 places where the tangent line has a slope of 0.
Are those usually going to be multiple choice?
Yes.
Yeah.
No. Free response question 2 years ago was you draw the derivative. Sketch the derivative.
Oh, wow. On the
Yeah, the one, online exam, yeah.
just be like, that would be so nice. No. That would really, is this
All right, moving on.
Thank God.
I lost my other page. Oh, there it is.
Are we going 79 or 77?
79. All right. Okay, so this is kind of weird. This says estimate the derivative f of 5 given the following table of values. So this is coming out of nowhere. Okay? It's like, what is this related to what we've been doing? But for some reason, AP likes to throw this in there. Okay? So looking at this, how do you estimate the slope at x equals 5 when you're not given a derivative and you're just given a table of values? Okay? So remember where derivatives come from. The background of the derivative is we took a bunch of secant lines and we had it approach the point, right? Remember that first graph I showed you? We had like a fancy sine wave like this, and then we just drew a bunch of secant lines until we got to the derivative or the slope of the tangent line, okay? So that's the background of this question. What is the slope of the secant line that's close to x equals 5? So that's all you do, is find the slope between the two points that are close to 5. So that's all you're doing is finding the slope. So you're going to say f prime of 5 is approximately, so y is on top, so it's 11 minus 0 over 2 minus 7.
What do you, what? X2 minus X.
Is that point
The slope of a line.
X2 minus X1 over Y2 minus Y1.
y2 minus y1 over x2 minus x1. Huh?
Is that point slope form?
That's a slope form. That's the formula for a slope.
Wait, you did Y1 minus Y2.
Okay, sorry.
Wait.
It doesn't actually matter the order as long as
It matters the bottom, that doesn't matter.
No. As long as you're consistent, order doesn't matter.
Yeah, it doesn't matter. Well, it'll be negative, it'll be positive.
Hey, look.
If you change the order from top to bottom, then it'll change
Oh,
the
you say
sign.
like if it was Y1, Y2.
7
Yeah, I got you.
minus
I'm very confused.
2, 0 minus 1.
So the Y's on top there, correct?
But y's are on top, yes. So that's it. That is answering that question. And I guarantee this is one of the free response questions on the AP test.
Really?
It makes it every year.
So you're telling me I'm gonna get
The same numbers?
I got 5, I'm gonna get 20.
I don't get it.
I don't get what he's
I'm
saying.
gonna do better tonight.
How is it graded out of 5? That makes no sense.
Huh? 5 is like an A and 4 is like a B. That's what it is.
Does it go in between values like 4.9?
No. Alright.
Why can't you be out of 100?
It's out of like 120. And then they just categorize it to 5, 4, 3, 2, 1.
Are there like
Alright, 15.
80 questions or something?
estimating a derivative. The height of a tree, a time t, blah blah blah. It's twice differentiable. Measured in meters. Select the value of ht are given in the table. Use the table to estimate h prime of 6.
Okay.
So basically doing the same thing we just did.
Yeah. We're doing 2 minus 6 and 3
Right?
minus 5.
So it's going to be, so we'll do it Luke's way. We'll do the second number first.
Negative 4. Negative 2.
You're getting negative 4 out.
I don't know.
Oh.
I'm getting 5 halves.
Yeah.
Same here.
Where are you getting negative 4s
Is
on?
that H or is that
It's the H, right? These are H's.
Wait.
Why did you put 11 in the front?
Wait, what the world?
Because he wanted me to.
Oh.
I don't know what I did.
It was confusing because it wasn't in the front. Okay.
wrong button.
Sorry, don't do that. Alright. Like,
6 minus 11 over 5 minus 7.
I'm sorry, allow it again?
You use 7 and 11 instead of 3 and 2.
Oh, okay. Because it says it wants me to approximate around 6. So you want to get as close to 6 as possible.
Yeah, 2 is closer to 6.
No. X values.
Wait, but you can.
Or T values in this case. Yeah.
5 halves like 2.5. So the tree is, when it's 5 years old, it's 6 feet high. Then when it's 6 years old, it's 2.5.
No, this is the rate of change, not the height. Right, it's growing at 2.5 meters per whatever it was, year.
Can't you find that a different one?
Yeah.
Just like think about it for a second and be like,
Alright, B. Using the correct units, interpret the meaning of this. Oh, look, this is what you just asked me to do.
Oh, really?
yeah.
Right, what is the interpretation of this? That means the tree is growing at approximately 2.5 meters per year.
Too fast. That's not fast,
I could
sorry.
have just said props.
That is fast.
So where do you get this? 5?
5 divided by 2 is 2.5.
Okay.
Oh, I'm missing something. When it's 6 years old. You gotta mention the time frame there, because it was h prime of 6. So here's what would happen on the AP test. Because I didn't mention 6, I would have gotten the whole problem wrong.
Wait, that would have been a problem if he does?
Yeah, these two are questions taken off the AP test.
So the rate changes as it gets older?
That's right.
But why'd you say
Just like the
approximately?
slope.
Huh?
Why'd you say approximately? Because it's between 5 and 7?
Well, generally speaking, you would say approximate.
Is 2.5 basically
You will.
the tangent line?
It's almost everything's an approximation.
Is 2.5 like the tangent line on the graph? Like the
Well, in our example, that's a secant line, but it is a approximation of the tangent line.
What's the difference between a secant and a tangent line?
Tangent lines is instantaneous, like at a specific point in time. A secant line is going to be between 2 points.
Okay. So if you just cross a single point, that could be a tangent line, but if it goes through like that 0 point, like a parabola, that 0 point, that could be a secant line.
No, that's still a tangent line. If you're talking about doing this, oops, I missed. That's still a tangent line.
But if you cross it, like choose like different, like it goes.
You mean like this?
Yeah.
That's a secant line.
Okay. What is it called if it like goes through a line and it stays with the line for like?
Tangent line.
Okay.
All right, 16. Continue the same type of problem.
It looks a little difficult though.
It looks difficult because they just gave you so many words.
Words are.
My favorite quote from a calculus student is, "There are just too many words." Alright, okay. Water is pumped into a tank at a rate modeled by that mess. Liters per hour for 0 to 8, where t is between 0 and 8. Where t is measured in hours. Water is removed from the tank at a rate modeled by r of t, which is the table. Where r is differentiable and decreasing on the interval from 0 to 8. Selected values are given. You started with at time t equals 0, there are 50,000 liters of water in the tank. See how it's kind of fuzzy on your paper?
Yeah.
That is a clippings from a free response question on an AP test.
Wow.
Okay?
Well, your student was right. There's too many words.
Yeah, in fact, I couldn't even read them correctly. All right, use the data in the table to estimate r prime of 2. So this one you just know how to do, right? You've done this already.
How to do it?
Yeah, just do the slope thing between these two.
Okay.
I know what the answer is.
No, Tucker.
No, Tucker.
You have to do R prime of 2 because it's the answer.
Do r prime of 2.
R prime of 2.
I don't know how picky they're going to be about the answer, but do r prime of 2.
1 minus 3.
My brain just stopped. Is that 240 over negative 2?
You can do it in your head?
I can do that in my head.
Yeah, that's
Did you get negative 120?
Yeah. I got positive
same
120. Oh, now I got
No,
negative.
it's negative 120.
Negative 120.
All right.
It's light work.
Oh, look at that. All those words, and all we're doing is this. All right.
But then we have to do the thingy.
Right, interpretation, right? So, what is that? What does R of T represent?
The time it took for the liters per hour.
Water is removed from the tank. So R prime of 2 is water is leaving the tank,
Water is removed.
Removed from the tank. Liters per hour.
is being removed from the tank.
It's pumped from the tank. Extracted.
Water is.
At, this is where it gets tricky. Do I put negative 120 or 120?
120.
No.
120.
120.
Because it already says removed.
120 liters per what?
Liters per hour.
Per hour?
Yeah.
You know,
Yes.
At when?
2 hours.
6 hours. 2
2
hours.
hours.
2 hours. That's weird. All that gibberish just was put that down.
Yeah.
Okay. I'm going to give you class time to begin your homework.
Thanks, Mr.
It's the next 2 pages. It's the next 2 pages. Alright. Alright, so there are 3 instances where the derivative does not exist. So here's the first one. We're looking at the graph of the absolute value of x minus 2. The graph looks like this. Page 78. That is the graph of absolute value of the quantity x minus 2. Alright, so the derivative does not exist at x equals 2. So whenever you have a sharp turn like that, the derivative does not exist. It's a sharp turn or a cusp. Okay? The cube root of x to the, cube root of x. Cube root of x is the same as x to the 1/3. Alright, and it looks.
Cube root. Oh, I thought you were doing cube.
Alright, here the tangent line is a vertical line. The tangent line is a vertical line. That's when the derivative does not exist. The tangent line is a vertical line.
How do you know where to put the points?
I'm just telling you where it doesn't exist. I'm not asking you to find them.
Can you explain why it doesn't exist or no?
Okay? What kind of a slope does a vertical line have?
Define.
Doesn't exist. Hence, it
Okay.
doesn't exist.
Okay.
Remember, derivative is supposed to describe the slope.
Yeah.
So
So
if the
X-
slope is not describable, then the derivative is undefined.
So x to the third though, that has a slope.
Excuse me?
X to the third has a slope. Or it has a point where there could be a derivative.
Huh?
X to the third has a point, or
Yeah.
a point's greater than okay.
Well, so does this. It just can't have it at x equals 0. All right. This one, we have a vertical asymptote at -1. So the graph looks like this. So where it's not continuous, it doesn't have a derivative. Where it's not continuous, it doesn't have a derivative. So hopefully this one was obvious, because one of the things is, if it's continuous, if it's differentiable, it's continuous. But you've noticed there are two ways it can be continuous but not be differentiable, right? These were two examples, the two left ones, where the function is continuous, but you still can't find the derivative at those specific values.
Is the cube root of something always going to have a tangent, vertical tangent on it?
Yeah. All right. This is going to be kind of weird. So you got to get, this is kind of hard to get your head around. All right. So we're going to do some practice with this. So what I have here is the actual function. And what I want to graph, and I want to graph it on this, is the derivative of this. Okay? So, but I'm going to do it in terms of looking at the slope of the graph. So here, let's look at this part right here. What's the slope right here?
0.
0. So that means the derivative will go through the x-axis there. For x equal that value, the derivative will be 0 because the slope of the function is 0. Now, to this side of it, to the right side of this x value, is that, what kind of slopes is that? Negative slopes. So that means it's going to be below the x-axis. And on the other side, what kind of slopes are those?
Positive.
Positive, because, right. The tangent lines look like this, right? You don't have to draw this tangent line, but the tangent line looks like that. That has a positive slope, so it's going to be on the positive side.
I have a
So,
question.
go ahead.
How do you, I get that you just drew lines to show which side is which, but how do you just randomly get that tangent line? Where does it come from?
I just drew a line that touches it.
So that tangent line could be anywhere?
Yeah.
So why?
That was just an example of one tangent line on that graph. That's all.
So there's
There's an infinite number of them.
Okay.
Why did you like why couldn't do you see like a point with the line in it, you know? Like on the x-axis you had the point going like left to right.
Yeah.
Can I do it like the negative on the left side?
Well, what did I just say about what kind of slope does this tangent line have? Positive. So it has to be above the x-axis. So no, you can't come down here and go up, because that would suggest that the slope of the tangent lines are negative. So when I drew this line, I was only thinking of, is the slope positive of the original function, or is the slope
So
negative of the original
the
function?
opposite with the slope.
No, it's the same as the slope. Okay, you're thinking direction. I'm just thinking of sign, S-I-G-N. Is this a positive sloped line?
Yeah.
Yes. So it's got so the derivative has to be above the line, above the x-axis.
But just because it's going down, it doesn't mean it's positive. So
I'm only thinking in terms of, is this up here a positive y value?
Okay.
I'm not saying the slope of the original function is going to match the slope of the derivative. They're not related. The slopes are not related. Okay? It's the slope is related to the y value of the derivative. Yeah.
So you couldn't have a tangent line that was below y equals 0.
Uh-huh.
Okay.
You mean like down here?
Yeah.
Right. That's still positive, right?
So if it was negative.
Well, you mean on this side? That's negative.
Yes, it
So it's the derivative is negative.
But the same line though, you would like change it.
When you say same line, I don't know what that means.
Like the same, like it was still going from left to right, like that one, not like this one.
Right.
I don't know.
I understand your confusion. So you need to see a lot of these before you begin to make the connection, okay? Because it's really hard to see. Remember I said this, because you're trying to connect y values with the slope of something, but right now you're trapped in the slope of this one is related to the slope of this one. But that's not what we're doing. We're not connecting the slope of this line with the slope of this line. We're saying the slope of this line and the y value of this line. Okay? So here. So our first thing I want to do on the second example is find where the slopes are 0. So there's a slope of 0 here and a slope of 0 here. And I'm pointing out the x values that give me those slope of 0. Okay? Now, on this side, on the right side of this x value, are these slopes positive or negative? Positive. So that means it's going to be above the line. Between these two x values, are these slopes positive or negative?
Negative.
Negative. So that means, but the thing is, I have to come back together. I have to come back to that one. Come back to that one. And then to the left of this one, what kind of slopes are these? Positive or negative? These are positive slopes.
Yeah.
So that means I'm going above the line.
So it's only negative for a short period of time.
Correct.
Does it matter how far you come down?
No. I mean, eventually it will, but for these sketches, it does not matter.
So this is the graph of the derivative?
Yes, this is a sketch approximating the derivative. I will be very lenient in terms of how low you go or how steep you go. Okay?
There's none
So you
for
can-
the second one or the third one?
I haven't started the third one yet.
I have a question.
Yes.
So if you were to draw a tangent line itself, could you put like, I don't know what point that is, that's 1, 2, 3, 4, 5. For x equals 5, the point that starts going up
Uh-huh.
for any behavior, could you draw a tangent line there and that would be true?
I don't understand what you mean by that would be true.
Like would that be one of the, like an acceptable tangent line?
Yeah.
Okay. Are there
Tangent lines can be anywhere on the graph. Except at corners, right? So there isn't a tangent line here.
Oh, so then why do you focus on if it's positive or negative?
Okay, because I can distinguish, it's easy to distinguish a positive slope. Since I can distinguish a positive slope, then I just have to have a positive y value. Also, the slope of 0 is easy to spot. So that's going to be a boundary, right? A slope of 0 is a boundary between positive and negative numbers. So that's why I focus on positive and negative. Okay, since I'm looking at just numbers, what other aspect of number can I focus on other than positive, negative, or 0? I mean, I probably could, but can you make any suggestions? What else
Is
I
it
can
like
focus
a whole
on?
number or is it a decimal?
Okay, so let's say, she suggests I can look at it as a whole number or a decimal. Is there anything that can distinguish a whole number from a decimal by looking at this graph?
Not actually.
No.
No, not really. So that would make it really difficult to focus on those two. But I can easily focus on positive and negative numbers.
Okay, do you usually only look at the y values?
Okay, so I'm looking at the slopes to convert them to y values. So yes, because that's what a derivative is. The y value of the derivative is the slope of the original function.
Okay.
Is it always going to be a degree
Oh, but you
lower?
use that to find like,
Yes.
and you use like the points to find what the slope is, right?
Uh-huh.
Oh, okay. So you just take those 2 points. Okay.
All right. Looking at this one. What is the slope of this line?
Negative.
Negative. So like -1. Maybe it's something different. Let's just say it's -1.
Yeah.
So that means it looks like this.
Interesting.
So why is the point below the x-axis there? Like, could it be like lower or higher or what?
We guess that the slope is -1, so I'm guessing that's about -1. If you guess -10, then yeah, you could be lower.
Oh, so the top one supposed to be at 1?
Yeah.
Is it because it's absolute value?
Yes.
Okay.
What happens if, like, does it matter if your holes are open or closed?
They should be open because you cannot find the derivative at a corner. Ready for the next example? Alright. Example 4. First find where the slopes of the tangent lines are 0. So there's one here, there's one there, and there's one there. Right. These are x values of where the slopes are 0. What's happening to the left side of my first little hatch mark?
Negative.
It's negative, so that means it's below the x-axis. And what's happening between these two?
Positive.
Positive, so it's above the x-axis, but remember it has to come back to that. And then what's happening between here and here?
Negative and
It's
positive.
negative. And then once I get to this point, it's positive again.
It doesn't matter which side you start on, right? I just start on right or the left.
You mean you start up here?
Yeah.
Yeah, that's fine.
And just to be clear, so you'd have to take for the tangent line, you have to take two of the points, plug them into the equation in order to find out what the slope of that is.
Okay, you're using too many pronouns for me to understand what you're saying. You're using pronouns without antecedents. That was a very mathematical approach to the English. You said this and that, and I don't know what those this and that's are.
So for the tangent line, there's a point at which they start the stuff, right? Which
There's
they
a
make.
tangent line, there's a point of tangency.
Yes.
Okay.
So you take the tangent line and you find 2 points, right?
Okay, I don't understand that part. Why find 2 points?
Just plugging in for y minus 1, y minus y 1, and x minus x1.
For what?
Point slope form?
So you find the equation of the tangent line?
Yeah.
Okay, go ahead.
And you plug that in order to find the equation of the line, or the derivative.
Okay, but we're not doing any of that. All we're doing is looking at is the slope positive or negative.
How was that college application?
All right. Next example. You have a point of discontinuity. So the derivative is going to be not continuous there. What kind of slopes are these?
Positive.
Positive. Right? But it's almost flat. So this one's almost flat. And it's positive.
Why is it below? Like, why does it start on 0? Or
Why is it closer? Because what can you say about these slopes? What are they approaching?
0.
0, so it's close to 0.
So you do both sides or not?
Hold on. Slow down. The second side is a little confusing, so hold on.
Confusion.
Yeah. Right? This was positive, right? These are slopes are increasing.
Right.
These slopes are positive. So it's got to be above the x-axis. What about these slopes?
It's decreasing.
They're negative. They're decreasing. So it's like this.
Oh. I'm thinking.
That would be confusing.
This is
Okay,
this is
Zion.
math, huh? Do you put arrows or no?
If you want to,
You not care?
I don't care.
I'm
so
not care.
even though it's not going to the negative direction, though.
Correct.
Why is it not? I'm trying to draw.
Okay? What is the slope here? So pick a tangent line. And is that a positive slope or a negative slope? So it's going to be below. Okay? And it doesn't like twist up, right? So it's going to stay negative. Right.
Structure of
That makes
space.
sense.
I read it.
This one is the most confusing one. So I'm going to just do it and then you just ask questions.
That's it.
That's it.
Are we gonna know to just do that?
So I'm going to tell you, this is the function y equals e to the x. The derivative of e to the x is e to the x. This is the one function where the derivative is of itself. It's a
So this is just an automatic win button.
yes.
Is the second derivative also e to that?
The second derivative is the same.
So just every
Third
derivative.
derivative is the same.
Yes. Since taking the derivative is
There's a second.
the same action,
Yeah.
it doesn't change.
Wow.
Dang, that's deep.
So, wait,
So,
why is that so there?
how would we, obviously we're doing like reverse derivative, but how would it change as you go